Nice. So, Kat and I were just having a chat about a video he posted on YouTube. Um, it was talking about the design for some OBS stuff. So he's we'll put a link somewhere you can watch the video. But basically, it's a discussion on you've got this process that's going to be generating some HTML or XML. XML that's an RSS feed. Is that right? So it's basically you want to generate an RSS feed given some data, and you're trying to work out, well, how do I structure that if I'm writing these things in basically assembler or a very low level construct available to you. Okay, yeah, so and we were discussing it over chat, and we went, hang on, let's draw some diagrams that will be easier to discuss it. Okay, let's assume they've watched that video, and then we can just dig straight into it and pick up where we were up to, I guess.
Yeah, I'm curious if you found my diagrams clear or confusing at all in that video.
Yeah, good question. It gave me a mental model I could use to then think about how to solve the problem. So I think it was good. So basically what you're saying is, within a WebAssembly component, there's some global variables, and then you've got some sort of memory that you've allocated, or that can be allocated in blocks, in pages, sorry. You're going, I want to be able to have some mechanism by which this component we're creating is able to get hold of the data it needs and spit it out as this Atom feed, right? RSS feed. So there's a bunch of problems with that. There's things like how do you escape text? How do you get the thing to give you the information in a way that you can then put it into your output without accidentally writing over memory or doing something weird, right?
Yep.
So, and I was saying, in our discussions, I was saying, well, I guess the key here is there's a couple of really cool things about WASM. One is that you've got these components that are sort of completely independent little sandboxes. Well, they've got their own memory allocation and stuff, so that you can think of them as separate little machines. But I'm assuming they can communicate still, right? So if one WASM component gives a memory address to another WASM component, can he write into that memory address he's given?
No. So I think that's what the upcoming model. There's a specification for what they call components. And I haven't studied the spec because it's sort of still in flux, so I'm just waiting for it to settle. So I think that's what that might let you do. At the moment, you can only have one memory in WebAssembly. There's always on that sort of list of things that are possibly coming. So they've sort of built it so you could have multiple memories, but it's just not.
Okay.
That's not specified out yet. So
yeah. All right. So you're going to end up with, that's interesting. So assuming we don't have that right now, then we were saying, so then you're going to need something that's in charge of allocating the memory. And as you say, each bit of logic will need to know whether it needs to have some working memory itself. Because if you want to be able to stream out the work, then you want things to effectively all be writing to this stream and concatenating to it and appending their stuff on the end, right? And for that to work, then you don't want somebody to allocate some memory in the middle of that and take up a page right in the center of what you're writing.
Exactly.
So you'd need some mechanism by which each block of logic has some way to go, well, I'm going to need a couple of pages just to myself or whatever up front so that they can grab what they need for their working set that they can work within. And then there's only allowed one thing that's allowed to just keep writing contiguously to memory. And he goes,
there's sort of, because if you, as I've sort of learned about this, I study it, but also try to simplify the model. I've got at the moment a bump allocator, which is just literally a pointer, you just keep bumping. And if you think about it like a stack, it's kind of just a bump allocator. And normally in normal programs, you have a stack per thread, but you wouldn't have more than one stack. But I'm actually kind of wondering if each little bit had its own page of segment of memory that it had, it could sort of each have their own stack. That's one way of thinking about it.
Yeah. So as soon as you have, so if the underlying mechanism is that every time I allocate myself a new page, from my perspective, they're contiguous, then and you want to take advantage of that to write an unknown length XML stream to memory, then you only want one actor within this little group of things that's allowed to keep adding more pages on, right?
It's unlimited access.
Which means everyone else would have their own fixed sandpit.
Right. And I sort of was realizing that the recording the video is helpful because I normally it's all just in my mind or write some docs or whatever. Speaking it out like this is really helpful because I actually realized I haven't considered that the output could be, how do you draw a box on this? The output could be, because I've just assumed that the output is the thing that's got unlimited access, but the output could actually be could have a budget. So it's streaming out, but it's like when you tell the end sort of consumer, the thing outside the WebAssembly module that's reading the final result, maybe it only reads one page at a time.
Right. So, and that was kind of where, as we were talking it through, we sort of ended up with this situation where you're going, well, if we've got these independent bits of logic, so you've got this thing that's going, I know how to write RSS, but I don't know the data, so I'm going to have to ask someone, give me the next item, and then give me the next title of the next item, right? Or maybe it's got some sort of cursor, so it's going, okay, move on to the next item. Now give me its title, give me its whatever, give me its whatever, right? Give me its description, give me its whatever, right? And as it grabs those bits of information, it knows how to encode that into the XML in the format that you want, but it doesn't know what the data is, so it's us getting the data from somewhere. But then we said some of those fields might need to be HTML escaped.
Saying, technically XML escape, I think it's usually just the same process.
XML escape, okay. And actually, stepping back from that for a second, so the very problem you've got where you go, you're asking someone else to give you some information. So you say, I want the description, please. Right? There's two ways of doing that. Either you give them some buffer and you go right into here, right? Or you give them a pointer to actually where you want it to be written anyway and say, right there, please, right? And in which case, that works really well as long as the text they're going to write in is of the format that you want it to be and that they don't overrun your allocated memory. So we were saying you'd end up with some sort of protocol where you can have people that are writers, other actors that are writers, and you can say, you can write to my thing, but then there needs to be a way that it can go, oh, I'm going to run out of space here. I'm going to need more space than that.
And I think that I mentioned in the video AWS, and you're very familiar with AWS, because I found their APIs really interesting, like SQS or whatever, and they've always got these limits, these hard limits. And so one way I look at that, I go, oh, surely one day they want to get rid of those limits because that's restricting. But I don't think they do, because having those limits lets them design the whole system to be really efficient. And if you can, I think there's an advantage to that.
Yeah, I think they often, as technology improves and those limits become just arbitrarily too small, they will sometimes up them. But as their capability improves, so they can do things in parallel, or they've re-architected to make that thing that was expensive easy, then they move those limits around. But
I get the sense that those limits aren't just some configuration thing, and they just change one variable, and then suddenly everything's. I think it's no, they've that number's important because that maps to page size that's going to be written to a disk, So
that's right.
I think it'll,
and you can, if you fix things down, you can go fast, right? It's like old computers. You'd have the Amiga, and you have all these games that would look amazing on it because the person writing for it knew exactly what the hardware was, right? Same with any GameCube or whatever those fix systems.
Nintendo Switch. The new Mario games have got awesome graphics, but it's things 2 generations old.
Yeah. Okay, so we were saying effectively one protocol would be whenever you say I want some text from someone is to say here's where you should write it, and this is how long is the maximum length it's allowed to be, right? And they can then come back with, well, here's the text I've given you, but and somehow tell you I either ran out of room or I'm finished. Or this is and so effectively how much did I write, I guess. Is another indicator of
and I think I can't memorize these APIs off the top of my head, but if you look at the POSIX Unix stuff because they were in a very constrained environment, all their APIs have, you can't just write unlimited bytes to a socket, it's usually like, no, I'm writing this chunk and then this chunk and then this chunk. Then I like let you know, oh, it's all done, or like, or they have like a convention.
Yeah, right.
To do that.
But so in my head, I'm going, well, assuming there was some way that they could say, write to the memory they were given, and then say, and by the way, I've still got more, and you can then go, oh, well, write the rest here. Here's an address, and here's a size, and then it would carry on writing, right? And you could do that process until it goes, I'm done, right? So that's going to be interesting in itself. In that if it literally just had, so with as a WASM component, you've got functions that you can import and export. So you've obviously imported some function that you're calling to say, write your things here. And then in calling a function, it's writing to that memory, but also has a return value as well, or not?
Well, that's the API design question.
So are functions void by definition in WASM, or can they return values?
What's that, sorry?
When you call an imported method, nothing stops you having a return value. Is that right?
They all can have as many arguments as you want. They can return anything that's import, whether it's imported, whether it's exported, or whether it's like internal WebAssembly. It's all the same.
And you were saying in one of your other videos too that basically everything's numbers. Is that true for return values too? They have to just be a number, or okay?
It's 32-bit number, 64-bit integer, or same with float, 32 or 64-bit float.
Okay, so you could have some mechanism by which the return value is always however much it wrote to the buffer, that you know where the end is, or some number that represents I ran out of room. So I filled the buffer and ran out. If you could do that, then you could go, great, all right, well I'll call you again, and potentially you pass something to say this is a continuation of the previous call. I'm not sure how you negotiate that.
It's probably worth. I ended up in one of the videos just drawing a sequence like this. So it's like what do we call this? I was calling the outside board the host. What do I call? I just say module. Calls next episode, and then like to host calls right episode description. So then like okay, but the problem is like what if the host has like more? So how does it let you? Because it could be
So but I mean, so these things are stateful, right? So you can say
that's right. And as a principle, I try to make things that at least have as less state as possible. Right. But this thing will definitely have some state.
Yeah. So for example, you could call a method on some host, whatever it is, the module outside of you, right? It goes and writes to the buffer that you told it to write to, and then in the response it goes, it gives you the number that represents the entire buffer length, say, right? And then you go, oh, that's the entire buffer. You've written the whole thing. You might have more. So then it just calls you again with continue, and like a specific method called a continue, and a new buffer parameters. And then you, being the one being called, have that context of you just told them you ran out of memory, so you can then carry on, right? And if you've got if you've got nothing left to write, you just do nothing and return 0. Right?
Because if you just somehow manage to get to write the exact same length that it was expected, the next call you just say, oh no, it's 0.
Yeah, and that way there's no extra thing, and you've been able to write to the buffer. It's all good, right? So we were saying that would work. So then you go, okay, well, but what if I need the person outside of this thing to XML escape the text? Then you go, well, in that case, I want some other process that knows how to do that, ideally, right? So we were saying, by definition, you can't let them write directly to the buffer because it's going to write some text, and then you're going to want to replace it with more text. So you're going to want to expand it by going, that angle bracket now needs to be an ampersand, whatever, right? Or whatever, LT, whatever.
Which is
and that
maybe
you'd write over the text they gave you, right? Which is what you were saying.
If this output was finite instead of infinite, I could avoid that problem, because then you would say, I'm just coming up with random names here, probably like consume output or something, and I don't know, it's the start pointer and the length or something like that. So maybe like every time it writes, every time it's got the XML, you call, and it's like, okay, it's like sort of like flush. This is really just, you could just call this flush. Like it's just ready to flush this out. And then like, but then it clears this out. So then we're like, the episode gets like closed or wherever we just so happen to be, and then we're like writing the next episode. So like that previous XML content's like gone. It just assumes that the host has read it, and if it's doing like the string concatenation on the other side.
Yeah, so I'm envisaging that we've got some sort of XML escaping thing that allocates itself a buffer, and then like so the thing calling it has got like its stream buffer, right? The one that it keeps allocating more stuff to. Sorry, off the side here. Keep scrolling up a little bit.
Right.
Oh, actually, zoom out a little bit. That's it. That's probably easier. I'll draw a bigger unit. Okay, so so this thing over here is like the overall XML buffer that's happening, right? Thing. Okay, and it's going. I want someone to inject a thing in here that is XML escaped. So it's going to go. I need an XML escaper, which is this thing. And then it's going to go, hey, can you, normally it would call someone else. Let's put another thing over here. This is the person that, let's zoom out. Yes, this one over here is the one writing it, right? So normally you'd go, you'd call over here and say, hey, can you write to my buffer, please? And he would write into your buffer, right? So instead, what you do is you create this thing in the middle, and you go, hey, can you write into my buffer, please? Because it knows it's going to write escaped text into its buffer, right? And it's going to get back a pointer that you can write to, an address you can write to, which is this address here, right? And then it's going to pass that address onto this thing over here, saying, hey, can you write to my buffer, please? And it's going to end up writing into that buffer, which this process is then going to copy across into this buffer over here, right? So its job then, if that same protocol is in place, you're going to say write to this buffer. It's going to write to it and then go, I filled that buffer. This thing's going to go. So you'd want to. You need to somehow communicate to this thing. So originally, when I was thinking about it, I was thinking you could give the function to this thing so that it called over to here saying write to my buffer. Because that way
you can have sort of pointers to functions in WebAssembly, but it's not as flexible as any like a pure proper functional language. You have like a table, and then you put the functions in a big table, and then you say like, oh, in the table it's function number 3. That's all you've got.
So if let's assume this thing is passive, then effectively what you'd be doing is saying, is that you would write to you'd create this thing which has its own internal buffer. You'd pass that buffer on to this guy and say, hey, write to my buffer. It would write to this temporary buffer, right? And at some point go, I've filled that buffer up.
Oh, with the escaping.
Yeah, because this is fixed.
Yeah, because that's the thing with escaping.
Unescaped. Yeah. So this here is raw, right? And it's writing raw to this buffer. This is only a small buffer, so it's going to get finished at some point.
Get full.
Right?
But
let's say it did all fit. Then it would literally write to this and say I'm done, right? Returning back some size. Then the thing that gets told I'm done is effectively then copying that data and escaping it, like copying it through to this buffer over here and writing it as escaped. Right?
Oh, escaping as it writes it on the that makes sense.
So it's streaming this and going every time it reads an ampersand, it writes out ampersand colon whatever, right? And if
because it's on the right. If the right hand side's the sort of unlimited buffer, you don't have to worry.
Exactly, and it's bigger, right? when you escape things, they expand rather than contract. So
yeah, exactly.
as you're pushing it across, it can just take a character, write it across all the way through, right? But if this first thing has run out of memory, then that doesn't matter, because you'll just fill up the buffer, copy it all across, and then you'll have written the size, and you'll know that you've filled the buffer and you need to redo it again, and you'll just call continue on this again, and it will, giving it the same address, and it will rewrite over itself in its buffer again. I don't know if I'm making that clear. And then
that makes sense.
and then again, the process is going to have to copy that and escape it again, right? Yeah. So I guess you get a bucket of text at a time, I guess, and have to process it. In my head originally, I was thinking it would be great if this was like its own WASM component. So, but that assumes that you can write to other people's pointers, right? Because you'd want, but I mean,
you could when you implement the import and export, you could in the host, because the host language is sort of more capable and can see everything. You could implement it so that one is like you wire them all together there, but that code is probably going to be a bit messy, and you'd want to work out some sensible patterns for that.
Yeah. So this is where.
And the philosophy what I'm trying to do is make the host do the least amount possible. Because the existing WebAssembly stuff, like with mscriptum, is like produces this WebAssembly module, but then there's like a whole bunch of boilerplate code that it's got in like JavaScript, and I want to have that amount of boilerplate and stuff, make it ideally disappear as much as I can.
Yeah, like I've been saying to you, I think there's I'd love to double down on just the isolation of these little components and their independence and their sandbox and their whatever. And I think that there's going to be this need to link them together. So you go, well, like dependency injection, where you go, I've got this set of interfaces, methods I expose, and I've got this set of methods I need satisfying. And something goes, oh, well, this other component satisfies those. It is the one that I want to plug into you, and then those interfaces plug together, and then you end up with a bigger system that's made of two smaller components. They're just wired together, and then you can build systems by saying, well, a system is just those three building blocks plugged together, and then that system is plugged into them. Because it's fractal, right? At any point in time, you can look at the whole system and go, what do you expose and what do you require? And it should just work. So I'd like to
composable, one mental model also have is like components. Just how easy it feels to set them together.
Exactly, yeah. So I'd really like, and I think when I did some work on dependency injection a long time ago, what I ended up with was the code very neatly split itself into like a Lego set. You had like all the building bricks that were like, these are the bricks that plug together, and then you'd have like the instruction manual that says, this is how everything gets wired. This is how you assemble the system you're trying to create. Right, and it might go, this is how you make a leg, or you've got 12 legs on this thing. Do that 12 times, and then plug those together in this way, right? And it was really like that sort of your code read like an instruction manual on how to assemble your system, and at the end you had a bit of code that went go, that sort of spun everything up. And and I'd love to see that. So that's why I was thinking about this thing in the middle is like a plug-inable. HTML thing that you go, you say I've got a buffer I need filling with some text from this guy, and it goes, hey that guy, here's a buffer to fill, and then it does the thing of filling your buffer from its buffer from and handling the fact that it's going, okay, there's pages and pages of this stuff, and you don't care because you're it's silent. It's invisible to you, I guess.
It's encapsulated, because that's like the best. When OO works the best is like I always was brought up with Objective-C, and that had much more of a message passing sort of mental paradigm. And so you just sort of like, I just want to do this particular task, and you like send this message. Almost to the ether, like you're just sort of sending it wherever. You sort of don't care how it's implemented. You just go, I need this handled, whichever appropriate object, is the one to handle it.
Yes. Yeah, exactly.
Yeah.
Yeah. So
responsibility.
Yeah, I really like that model too. It's like Smalltalk and Ruby, like this idea of there are objects that are instances of a thing. They're not classes that are a template for a thing, and the objects communicate with each other. And like Erlang, you've got an inbox and you deal with your messages and you type them out, right? It's a really
and you can forward messages and it's like, actually that's cool, I got this message, but I'm not the thing to handle this. I'll forward it onto
that was one of the things I put in my dependency injection framework, actually, that made it really clean, like compared to other people's frameworks, was the idea that you'd go, well, here is a scope, and within that scope, you had events that were occurring, and you could listen to those events. But to listen to them, you just implemented on your the interface I listened to, and then that type, and then by the nature of the wiring, it would go, oh, you're a listener of that type, and then whenever that happens, I'll let you know, right? And because your design was hierarchical, like you had a tree of stuff in your system, then you naturally had these scopes within which an event occurs and gets broadcast within that scope. So like you can have two motors, and you can have like a home event that would home the motor, but they wouldn't be both homed at the same time. The home event would only bubble up to their local state. And so I had this idea of like a broadcaster, effectively, that you could define at a different layer, and it would become, it would be able to bounce the message around to other states. But it sounds complicated, but it actually really clean.
No, I get it.
So you go, these messages are global at this state, at this part of my state, not state, system. Subsystem systems. Anyway, so it'd be as I said, I to you earlier, I think a sort of mechanism like that makes components really easy to
that's the vision I want to eventually get to, where it does I just get the XML XML maker, XML builder module, and then you just go implement a bit of an interface, and then it just does it.
Yeah, exactly. Yeah, and the nice thing about it too was your building blocks didn't know about the dependency injection framework, but there was some interfaces they could implement that meant that the framework knew how to handle them. So, and then that made them really testable as well, because you could you just call the methods on the thing, and it's like, this event has occurred, and it would go, okay, and handle the event, right? You didn't have to do some magic like broadcasting a thing with a mock thing, or you just called a method on an object, right? That's all it was, right? So that I love that design philosophy, that the components don't know, they're just building blocks. Okay, cool. So the thing that's still unclear in my head is that it's the who's calling a method on, like, if we could set this sort of design up, then you go, well, who's calling the method on what, and how do you make it into a chain, right? Because it would be nice if I really feel like I want interfaces, like, because I want to be able to go. There's a writer interface, and you can say text, and then you go, need more room, and it goes, okay, and you go text, need more room, right? So that that little protocol gets handled in a really standard way, and then effectively you're just going, rather than me giving you my document as the right thing you're writing to, I give you this fake buffer thing as the thing you're writing to, and you don't care, but that fake buffer thing knows when you've written to it, so that it can then write to me, right? And let me become a chain, right? And for that to work, you've got polymorphism and substitution, right? You need two things implementing the same interface protocol. So we have to agree on what that protocol is, which sounds like something where you can go, this is what I'm trying to achieve, here's the buffer to put your data into, and this is what you should do when you're done, like, or maybe just it's like it feels from go on.
Just from an implementation point of view, when you've got polymorphism, my understanding is there's sort of two ways of doing it. It's either pure, very dynamic, so there's sort of like anything could implement this interface. Maybe even like at runtime, things are being registered that implement this interface. So then you have to sort of have like a fat pointer, or like in the pointer itself, that you pass around that's implementing this thing, it has to encode what its like classes, like what it is in this thing that you pass around, because the system has to sort of pick up, okay, need to get down to concrete. I need to call an actual method at some point, so I need to be able to ask it, okay, what's the actual concrete implementation of this? That's one way of seeing. The other way of seeing is that you basically, it knows every single thing that's implemented this interface at compile time, and it's only a finite list. So then it has a little table somewhere where it sort of like stores that away. And then when you pass things around, I guess I'm sort of saying two different things there. I think you could either just sort of say like, I'm number 2 in that table implementing this list and you can just look it up, or I think if you have a smart enough compiler, the interface actually gets blurred away. It knows there's concrete objects always being passed here, and it sort of, it feels dynamic, but it's actually not.
Yes.
Yeah. I'd be curious about that. I don't know how hard any of that stuff is to implement.
To me, this feels like some sort of decorator when you're saying, like, I'm going to be caught asking this thing to write to something. And really, I can choose which pointer I give it to. It's almost like that thing when you go, I've got a stack of hierarchy of objects within a structure or something, and you go, I want to home the motor, and the motor goes, I want to home the state machine, and the state machine goes, I've got to home the thing. And if they're asynchronous, at some point they go, I'm done now, right? And when you're the middleman, you can either go, I'm going to make my own callback for you to call, and when you call it, I'll call the callback I was given, or you can take the callback you were given and pass it on, right, to the person below you. And the implementation, no one cares. They just get a callback and it goes straight through, as long as you don't care when it happens, right?
Sort of like middleware.
Yeah, that idea of this being like you're writing to a buffer.
But from my point of view, all I get is this little interface. It's like I get one end of this pipe. I can like shove bytes into it.
Yeah.
I sort of don't know what happens on the other end.
Yeah, I'm just thinking of it like this idea of you call a method, you call something and it writes to somewhere and then tells you it's done. And you don't care whether that thing that's being written to, like, it'd be nice. I'm fuzzy in my head about the flow of communication here. Right?
I think you don't care if it's like directly getting the data and directly writing it to memory, or if it's like doing more computation, like it's sort of like a function, doing more computation, and then it passes it on to the next step. Like you don't really, from your point of view, it's just the same interface. You don't really want to think about it.
Yes.
Which is great, like you were saying, it's great for testing as well, because you can sort of insert yourself into that middle layer and go, okay, like, this is the output I'm expecting here.
With my NDI dependency injection framework, we use decorators a lot. There was a lot of that idea of going, well, I'm just going to wrap that thing in a same interface and pass it up. Okay, cool.
One of my pet hates with to burn it all around, one of my pet hates with what I sometimes see with C# interfaces is that only one thing implements it. It's like if only one thing implements it, do you really need? Why not just use the concrete thing?
Yeah, right. Yeah, interestingly, I had the opposite thing sometimes too. That I would end up creating an interface with nothing in it, just as a way to tell the dependency injection framework that this was a different thing to that other thing, so that I could say, well, give me this interface. You'd get the one that was the only one that was implementing that. It was interesting. It only happened a couple of times, but I was like, that's a really odd. Like, it really went against my intention originally, but it was quite a clean solution. Anyway,
the bit of trivia for you, tangent on tangent. The Swift added a sendable protocol, which I think they copied from Rust, because they needed some way of saying that which stuff is okay to be sent across threads. And it's a protocol with like nothing in it. But they couldn't figure out what to. It's like, but it doesn't need any. We just tend to sort of mark these things.
Exactly. Yeah. It's like the metadata associated with the information. Cool. Okay. We should probably wrap up. I say, yeah, I'll be really interested to see how this turns out. I really love this idea of like an HTML escaper, and if we can find a way to make that some sort of module that you can plug into the other bits and it just works as a decorator type thing, then I think that mechanism will work generically elsewhere. Yeah. Cool. Okay. Well, all right. Look, we'll have another chat about this once we've made some more progress.
Yeah. That'd be cool. Yeah, probably. The way my process is usually to create 6 different implementations and then let them fight and see which one works best. So that's probably what I'll do.
That's awesome. All right. Well, I hope this has been fun for you too.
Cool.
I'll catch you later.
Cool. Yeah. See you. This is awesome.